If you want to build an AI assistant that can answer questions about your company data, things like Slack conversations, Confluence documentation, Google Docs, you will likely realize that standard solutions and models, things like ChatGPT or Claude, cannot do it out of the box. The problem is knowledge gap. Large language models are trained on public data with a specific cutoff date. They don't know about your private documentation, about your latest security policies or project requirements. This is where RAG, Retrieval Augmented Generation, comes in. Think of it as context injection. We search for specific text in our documents, Slack conversations, even code. Then we extract this text or information, and then we inject it into our model context. One of the main engineering challenge with RAG is to build index. And in order to build index, you need to create chunks. But this creates another problem. If you try to chunk your data in a fixed manner, you might lose the context. I'll give you an example. The king stood in the castle. Suddenly he felt a fear because someone was behind him. Now let's imagine that RAG splits these two sentences specifically by sentence. First sentence, king stood in the castle. Second sentence, he felt fear because someone stood behind him. What happens if you ask why king felt fear? RAG might retrieve first sentence or second sentence. If it retrieves first sentence, model doesn't know why. Model knows about king. If we retrieve second sentence, we know that someone felt fear because someone stood behind him, but we don't know nothing about king. This is the problem with fixed chunking. There are multiple types of chunking. One of them I already mentioned, fixed chunking. Another one is semantic chunking. Also, we have recursive chunking and content type aware chunking. Today I'm gonna benchmark all of them, and we're gonna compare which one is better. For that I will use Postgres database with pgvector extension. This is a very cheap and very straightforward approach. Of course, we can use other types of databases like OpenSearch, but locally it's much easier to set up Postgres. On this slide you can see that what architecture we will use. First we have our content, which is GitLab handbook. I'm going to explain later why do we use GitLab handbook. Then we have Markdown loader. Then we use different chunking strategies to build index. We will use also fast embed model to build this index. We will use pgvector store based on Postgres SQL and pgvector extension. And another part is retrieval. Retrieval part we will use search in vector database. Then we inject result of search into context using top key chunks. We will not use any filtering or another evaluation strategies in retrieval because currently we only evaluate indexing. And last but not least, for benchmarking and evaluation, we will use RAGAS framework. It's a very popular and very enhanced framework for RAG evaluation. For our test data, we will use GitHub handbook. It's a perfect example. It has more than 2,000 Markdown pages. It's a policy heavy, and it's a perfect example for corporate documentation. We are testing 4 strategies. First is fixed token chunking. It splits fixed token by boundaries, zero document structure awareness. It can split tables, it can split sentences in half. Another one is recursive character splitting. This is industry standard. It respects natural paragraph and sentence boundaries. Third one is semantic chunking. Semantic chunking is using embedded model to group similar content together in groups. And the most interesting chunking strategy for our case is Markdown chunking. I would also call it type-aware chunking because if we have, for example, HTML documents, if we have Google documents, which is XML under the hood, we can use specific type of chunkers per content. And for benchmarking, we will use RAGAS. It's a popular framework which used for evaluation of RAG. We will use 25 questions. We will define answer for each question, and RAGAS will evaluate model response and compare it to answer we defined. I prepared local benchmarking scripts which contains of 2 parts. First one is build index. So this is a script which grabs all our GitHub GitLab handbook, and using different chunking strategies, it's splitting chunks and building index. Let's look at strategies we have. We have fixed size, recursive chunker character, semantic chunking, and markdown syntax-aware chunker. All of them we getting from LlamaIndex. It's also a popular framework for building indexes. So let's start building index. I'm gonna create virtual environment. As usual, everything I show you here will be available on my GitHub. And now we can start building index. The index is building. I'm gonna skip video so we don't have to wait. Our index has been built. For every type of chunkers, it created a table, separate table. Let's look at the results. Fixed size chunker, as we can see, sometimes splitted sentences in half. And also it contains broken markdown. Recursive character looks a little bit better. We don't see a lot of sentences splitted in half. Semantic chunker also looks better, but we don't have proper markdown, as we can see. And syntax-aware chunker, as we can see here, every chunk is a separate section of markdown. Now let's look at our benchmark evaluation code. What does it do? It loads connection to pgvector store, then it loads index by strategy. We use same chunking strategy factory, which we used for building index. Then we use RAGAS evaluator, and we evaluate based on top 3 chunks retrieved from RAG. And we have questions to evaluate. Let's look at them. We have around 25 questions, and we have reference. Reference is basically an answer which we compare to. So when model gives us answer based on retrieved context, what we do next, we compare it with reference. It's done everything by the hood, under the hood in RAGAS framework. If we look inside evaluator, we have prompt template. Context information is below. This context is basically data we retrieved from RAG. Then we have this prompt, and we have a question. And basically everything else is building a report in Markdown file. I've already executed this benchmark. It's pretty slow because we have 4 indexes and 25 questions. But here are results. For every question we have faithfulness and context precision. And also this generates a more specific report which shows you what chunk was retrieved and what question and reference we had. I prepared results based on our benchmark. As we can see, fixed chunker gave us worst results, which is expected. It's not optimal one, but it's a quicker and cheaper one. Recursive chunker is a little bit better, and it's acceptable. You can use it for simple RAG if you want to build something simple and quick. Semantic chunker didn't work well in this setup, but semantic chunker usually works good when you have good embedded model and you have content which is doesn't have specific markdowns or text like HTML. In that case, semantic chunker will be better. And Markdown parser is the best one because it's actually content type aware. And from my experience, I can say that type aware chunkers like Markdown, HTML parsers, usually they work best in these types of content with tags and markdowns and specific formatting. But for production, for your company, you cannot, of course, use this local setup, especially if you have a lot of documents, a lot of code, a lot of Slack conversation. Therefore, I prepared some architecture on AWS for you, which you can use for your company RAG building. This architecture is only contains index building part. I created a small part in the bottom for retrieval, but of course, I would say this is just for an example, because for retrieval, it might be a little bit more complicated than this. But for indexing, this is actually good architecture. And in next video, we're gonna build it online and we're gonna try and see how it works.